I'm going to talk about sums and differences of radical expressions. Okay? The key idea is that you can only add and subtract radicals of the same kind. Okay? So the square root of 3 plus the square root of 2, you can't simplify that. Okay? It's not going to equal, the sum is not going to equal the square root of 6 or the square root of 5. Okay? There's no way to express this sum as a single radical. Likewise, if you had a difference like the square root of 5 minus the square root of 3, there's no way to combine, there's no way to find an equivalent single radical that's equal to this difference. It's not going to be equal to the square root of 2 or the square root of 15 or whatever other number you dream up using the 5 and the 3. Okay? On the other hand, you could add together the expressions 2 root 2 and 5 root 2. That would give 7 root 2. Okay? Or 6 root 5 minus 3 root 5, that would give 3 root 5. Okay? So the blue sum and the blue difference, those involve radicals that are the same kind. See the difference? All right. Now, sometimes if you don't have radicals of the same kind, you can simplify radicals and they'll turn out to be the same kind after you simplify them. Okay? So, for example, suppose we were adding the square root of 12 to the square root of 27. Those are not the same kind. However, the square root of 12, we can write that as 2 root 3. And the square root of 27, we can write that as 3 root 3. And lo and behold, the right side of the equation, we can simplify that sum, and we get 5 root 3. Okay? Now, I would like you to try an example where you have to simplify radicals and then you can simplify the expression. So would you please try to simplify the square root of 18 minus the square root of 8? Do that. Pause the video and try that now, please. Okay, I'll go ahead and do it also. So the square root of 18, 18 is 9 times 2, so 3 root 2 is what the first radical can be replaced with. Square root of 8, 8 is 4 times 2, so I'm going to replace root 8 with 2 root 2. And lo and behold, I have a difference that I can simplify now, and I get a single root 2. Okay? Now, let's have you try some other ones to just get a little bit more practice, and then that'll be it for this video. So can you please try to simplify the following radical expressions? All right, pause the video and see how much you can simplify these three, please. Okay, so the first one simplifies to 5 root a. The second one, I've got 3 root 6 plus 2 root 6 minus root 6. That's 4 root 6. And the last one, we need to simplify the 27 first. 27 is 9 times 3, so 3 root 3 plus 4 root 3 is the equivalent sum, and that simplifies to 7 root 3. Okay, now let's do one more involving 3 radicals with variables and involving the need for some of the radicals to be simplified. So I'm going to throw everything at you in one problem now. All right? If you can do this one, you're in good shape. 3 root 3x minus the square root of 12x plus 5 times the square root of 48x. So pause the video and see what you can do with this one to simplify. All right, here's the best I can do. The 3 root 3x, I really can't do anything with that. The 12x, I can do something with the 12. So 12 is 4 times 3, so 2 root 3x. And for the last one, 48 is 3 times 16, so I can take out a 4, and I have that, okay? Now, I could have done the 5 times 4 in my head, but I wanted to set an example that it's not, you don't really gain too much trying to do too much in your head, especially when paper is cheap, right? I'm not even using paper. I'm using virtual paper, you could say. So I guess that's even cheaper. All right, so now I have pieces all involving the same radical. So let's see, I have 3 root 3x minus 2 root 3x. You know what, let me just, to continue with my theme of not trying to be a hero and doing everything at once, let me combine the first two. Okay, and then let me now simplify the last piece. 5 times 4 gives 20 root 3x. And putting it all together, 21 times the square root of 3x. And I hope that is what you got.